All right, we're getting ready to start thermochemistry in AP Chem, and some of the concepts that we learned in honors chemistry and thermochemistry specifically are going to become critical components for this chapter that we're getting ready to start. So this screencast allows you to look back at a few of those previous items and helps you remember how you do them or what is involved. So here's a list of things that we learned in thermochemistry, which was chapter 5 way back in honors chemistry, probably in the first half of the year. So if you read down through these, I will try and give you some reminders or things that will help you solve them or use them again here in chapter 19 in AP Chem. The first item is Hess's Law, and Hess's Law said that the delta H's for each of the intermediate steps could be added up to find the overall sum of the delta H for all the steps. And so things that we were doing with delta H was we were able to flip a reaction, and when you flipped a reaction, you changed the sign. Or maybe we multiplied the whole reaction by a factor of 2, so we would multiply our delta H value by a 2. You could also divide, and if you were really into a problem that was super challenging, maybe you had to use a fraction where you would multiply by 3 and divide by 4. Hess's Law problems will always give you several steps and their delta H values, and then it'll tell you what overall reaction it wants you to find the delta H for. So they were pretty simple once you got the hang of them. The next line here says the delta H for the reaction. So this would be enthalpy of formation or enthalpy of reaction is when you take the sum of the products, delta H values, minus the sum of the reactants, delta H values. Now the N and M that are listed there are the coefficients. So if you had a reaction where there was 2 H2O and they were on the products, you would take that factor, that coefficient of 2, and multiply it by the delta H value that you looked up in a chart in the appendix. Keep in mind, some of the values are 0, and you do have to be conscious of the solid, liquid, or gas or aqueous states listed in the chemical equation. The third thing in our list here is Q equals MC delta T, and that is called calorimetry. And Q is heat, M is mass in grams, C is a constant called specific heat, and delta T was the change in the temperature. You were able to oftentimes find the heat or find the temperature change depending on the information that they give you. A lot of times these were in water, but that's not exclusive. There were other C specific heat values. Our next bullet is endothermic, is saying that the delta H value is larger than 0, and exothermic, the delta H value is less than 0. So if you have a positive delta H, then you would have an endothermic reaction, and if you have a negative delta H, you would have an exothermic reaction. Remember, we spent a lot of time looking at if heat was released or given off. In other words, that would be telling us which direction the heat was moving. So you'll need to be aware of the context clues in the word problem. It may be telling you that the heat is negative or positive, and then we even further took and transferred that knowledge into whether the heat was a product or a reactant, depending on if it was positive or negative. Our next item listed is kilojoules and calories. So those are the units that we were using to measure our heat. Most frequently you will see kilojoules. I know almost all of the values we use for the thermochemistry here in AP Chem are going to use kilojoules, but occasionally when you're solving for entropy, you will see it listed in the back of the book in joules. So be aware that you need to change all the units to the same value, whether it's joules or kilojoules. And occasionally they will give you calories, and so the conversion for 1 calorie is 4.184 joules. Heat capacity was the amount of heat it would take to change the mass that you had of your sample, a specific number of temperature degrees. The next item is delta E, is the change in energy. So the change in energy was based on work, which is Q, and I'm sorry, not work. The change in energy was based on Q, which is heat, and work, which is W. So you were looking in your word problems to decide if the Q and the W were given off or taken in. We spent a lot of time looking at, was it going into the system or out of the system? So you would assign a sign, positive or negative, depending on if the heat and the work were going into the system or if they were going out to the surroundings. And then the last bullet point is potential and kinetic energy. Potential is a stored energy, and kinetic was the energy of motion. So if you don't recall these items, make sure that you go back and either read in your textbook or brush up on them a little bit further with some additional resources that you may have access to.